Okay, 1.7, inverse functions. What is an inverse function?
It's a function that's inverted.
What does that mean?
Exactly what I said.
It's what is the inverse of 4?
Negative 4.
Okay, so it's like the opposite of what it is, okay? So an inverse function is the same thing. So if I have the function f of x equals x plus 4, what is the inverse function of that? What would be the inverse function of x plus 4? X minus 4. Okay? If you see something written this way with the f to the negative 1, that stands for inverse function. Okay, that is the inverse. Finding the inverse of a function, okay, we're going to talk about how to find that. Let's say you have f of x equals 4x. And says find the inverse. Okay. If I'm finding the inverse, okay, of f of x equals 4x, okay, what do you think that would be? X over 4. Because here I'm multiplying, so instead I have to divide. So my inverse function is x over 4. The problem is you can't stop there. You have to double check this and make sure that you are correct, okay? And when you make sure that you're correct, you have to plug the inverse function into the function of x. So I'm plugging and I'm doing compositions, hence why we had to do compositions before this. And you also have to plug the regular function into the inverse function of x. If they both come out to equal x, they are truly inverse functions of each other. So on this one, I am plugging this equation into the x of that equation. So I would get f of x equals 4 times x over 4. This reduces and cancels and you get x. So far it's working. Over here, I am plugging this equation in to the x on this equation. So I have the inverse function of x equals, okay, 4x over 4. Once again, they cancel and you have x. So these are truly inverse functions of each other. On your homework tonight, if you do not show both steps, it will just be wrong. Okay, so when we're finding inverse functions, we have to plug functions into each other. So, let's find the inverse function of f of x equals x minus 6. How do I find the inverse function of f of x equals x minus 6?
It's either negative 6 or 6.
Yes, so my inverse function should be x plus 6. But now I have to verify by plugging the function of, the inverse function of x into x. I'm plugging the function of x into the inverse function of x. So first we start with plugging this x into there. Okay, so you get x plus 6 minus 6. That's the function. Okay, these cancel, you're left with x. Here you're plugging the function of x into the inverse function. So I'm plugging this x into here. I'm plugging that equation into that x. So I have x minus 6. You're going to stop. Plus 6. Those end up canceling, you get x again. So when you are checking for inverse, you should always get x out. If you don't get x out, you've done something wrong and it's not truly the inverse function. Okay. Let's look at this. Let's verify this inverse function. It says verify that these are inverse functions of each other. And it gives us f of x equals 2x cubed minus 3 and g of x equals the cube root of x plus 1 over 2. Okay, so to verify this, I have to do composition and plug g, I have to say f of g of x, and I have to say g of f of x. And if they both come out to equal x, they are inverse functions of each other. So I'm starting by plugging this whole equation into that x. So I have 2, and then I have times the cube root of x plus 1 over 2 cubed minus 1. What happens when you have a cube root raised to the cube power? They cancel. So this cancels, and you're left with 2 times x plus 1 over 2 minus 1. What can I do here? The 2's cancel, so I'm left with x plus 1 minus 1, which gives me x. So it works in that scenario. Now we have to plug this function into that x. So you have the cube root of 2x cubed minus 1 plus 1 over 2. Okay? So first things first, the negative and the positive cancel, and I have the cube root of 2x cubed over 2. The 2's cancel, and I can take the cube root of x cubed, and I get x. I verified that those are inverse functions of each other. Here's another scenario. Which of the functions is the inverse function of this? Let's say it says, what is the inverse of f of x equals 5 over x minus 2? Is it A, g of x equals x minus 2 over 5, or is it B, h of x equals 5 over x plus 2? Okay, so the only way to actually do this is to plug them in and check. So I'm going to start with A, and I'm going to say f of g of x. So I'm plugging this into that x. So you get 5 over x minus 2 over 5 minus 2. Okay, what can I do from there? What do you mean take out a 5? You can't take out a 5 because this 5, it's a fraction over a fraction. So I need to multiply this bottom part by 5 over 1 so that it cancels out here. But then I have to multiply also the top by 5 over 1. So you end up getting 25 on top. And on bottom, you get x minus 2 minus 10. So you end up getting 25 over x minus 12. Does that equal x? No. So this is not an inverse function. If we check B, okay, and we plug this equation into that x, okay, I get 5 over x plus 2 minus 2. Okay? So these end up canceling. And then you have 5 over 5x. To get that fraction out of the bottom, you flip and multiply x over 5, and that means the top gets multiplied by x over 5, which means this cancel, the 5's cancel, and you are left with x. So b is the inverse function. You're going to have to be able to prove those things on your homework. Last thing for today, graphing inverse functions, okay? So the graph of a function of f and its inverse function, f to the negative 1, are related to each other in the following way, okay? If you have a point a, b, then on an inverse function, it's flipped, it's ba. So if I have a point that is 1, 2, the inverse would be 2, 1. Okay, it's just the opposite. So when you have a graph and it says, what is the inverse of this graph, okay, it is the opposite of all the points. You can also plug those into your graphing calculator and solve from there. So that shouldn't be a problem. Let's do some homework.